Hi all, this is problem 2. It is here. I'm going to call this unknown load R, but yeah, the idea behind using, sorry, I'm remaking this video, so I keep forgetting to state what my assumptions are. We're going to basically be using everyone's favorite method of superposition. We're going to look at two cases. We're going to look at one with just the distributed load. And then we're going to look at one with a point load here. Sorry. Now you're going to find an equation for the deflection at this point due to each of these load cases. So for example, over here, let's look at what is the deflected shape of this beam. Do you guys agree that it's just going to bend downwards? Like this? Because I have some distributed load applied to it. And over here, do you guys agree that this is gonna bend upwards because I have a point load in the upwards direction? And usually if I superimpose these two, then I should end up with a beam that has zero deflection at this point. Delta R, and this is delta omega. So I'm gonna be like, well, what do I do now? Yeah, you just need to find the deflection here. You already know the angle at theta, so how to say this? Yeah, you already know the angle at theta, so all you yeah, when you draw their tangent line, when you draw it in blue, this is gonna be, if you draw your I'm gonna pull this down here, and if you draw your tangent line here, this will be your, what is this point? This point is TCA, so this is TCA equals moment. The moment of your moment diagram, the first area of your moment diagram, from A to C. And that will give you delta C. You don't have any corrections to make because your theta here is 0. Now over here, you're going to get, on the other side, you have a second moment equation. So let's call this delta C minus to indicate that it's from the left, going from the, I'm sorry. Yeah, let's just call this delta C1. Now let's pull this diagram over here. I was thinking from left to right, but I forgot that we're no longer working with number 1. Yes, and then over here, for your, let's try to keep these consistent at least. For your second diagram, you're going to do the same thing. Let's call this 1, let's call this 2. Equals moment EI, A to C equals delta C2. Now, this equation will be in terms of P and L, P, L, E, and I. This equation will be in terms of R, L, E, and I. And you want to set these equal to each other. and solve for r. There are a couple other methods of doing this method. Before I was including including r in my first equation and then just setting it equal to 0, but I believe that this method is probably simpler than the method I was using in the last homework set. So yeah, just keep that in mind. Yeah, let us know if you have any questions. I think if you can do number 1 fine, you should be able to do number 2 fine. Yeah, number 2 is just testing your ability to recognize. Oh no, it's just a good problem. I don't know what it's trying to test. There is a meaning here somewhere, but I'm too tired right now to decipher it. But yeah, let us know if you have any questions.